All right, hey guys, welcome. This is Prysmatic Labs Beacon Chain Sync Up with their team in order to open up issues and PRs relevant to the task. So I guess if anyone has anything to discuss beforehand, we can talk about it now. Otherwise, I guess let's just we can dive in and start doing some design review stuff. All good?
Good.
All right.
Yep. Awesome. Cool. So one of us should probably share the screen about the Beacon Chain doc, and then we can go from there. I'll be taking some notes, so. Can any of you guys share screen?
Yeah, I can do it. Hang on, let me open Okay, can you pin my screen so that it's being shared no matter who's talking?
Yeah, present to everyone. Right, I can see it.
Okay.
So, yeah, so I guess, the important thing that we want to come out of this meeting is to make sure that there are no unanswered questions about major implementation details, and make sure that everyone is kind of very clear on what we're going to build. And then from there on, we can assign tasks. So, I guess, want to begin with, discussing some of the goals and what's going to be included and not.
Is that a comment from me? I didn't hear.
Oh, just talking about kind of the goals section. So, I think the idea is that, we ideally want to be able to just keep a lot of our code similar to what it is today, but only replace kind of the things where the SMC had responsibilities with Beacon Chain operations. So, I think that should be pretty feasible. We will have to change, however, the responsibilities of the actors, which is something that we're going to go over here. But one of the major things that we're not going to include in the Ruby release are going to be rewards and penalties. And there's a section here on processing shard transactions, shard collations. So what do you guys mean by this? You mean that the Beacon Chain won't be storing anything, or we won't be doing any sort of fork choice rule in the shards? What does this mean?
I think this is still up to debate, so I'm open to what you guys think. So based on the phase zero definition that from the Berlin meeting, that people were suggesting that we should 100% focus on the Beacon Chain. Just make sure the Beacon Chain is a proof of stake chain, that Beacon Chain works where there's a fork choice rule, where there's a state transition, where basically the validators will slash if they behave poorly, and that goes without any shards. So that's basically the current phase zero definition, and I'm not sure how that aligns with the current Ruby release.
Got it. So with the current Ruby release, we already have serialization of collation bodies. We already have ability to pass that data around or request it from other actors. Mm-hmm. So I mean, if what this would mean, I guess it would be that we would have a proposer submitting a transaction to this Beacon Chain, and kind of would submit like the cross links.
Basically, I think that just means that we will have proposer and then a tester. Proposers that make blocks in the Beacon Chain, and then a testers basically sign off on the Beacon Chain. but then we won't have notaries that sign cross-link. And I'm not sure whether that's the way that we want to do for our Ruby release.
We just add a quick thing. So, so simply testers, proposers, but no notaries signing off on cross links.
So,
Cool.
yeah, I have a question, and I'm sorry if we already covered it. I might have missed it. But why are rewards and penalties not part of the Ruby system?
I actually think based on the phase 0 spec, we should have rewards and penalties. That's what I think. Because that's a huge part of proof of stake, and that's a huge part of Beacon Chain based on rewards and penalties.
So the slasher mechanism, right?
Yeah.
You're saying, Terrence, that we should have that or not?
Yeah.
Yeah. So
yeah, the reason why I was going to say the reason why I wrote this here is because the specific details for how slashing works isn't really in the spec.
Not yet.
And how, basically how validators can withdraw their balance isn't in the spec either. So we could just like have some kind of constant for how much is rewarded or how much is slashed, but then we don't really know what those details are going to be yet.
I think the rewards and the penalties are actually within the Casper white paper, but I'm not sure whether they are going to be.
Yeah, I think it should be exactly the same as Casper FFG.
Yeah, I'm not sure if they will be using it. I think it's gonna be very close to that. So basically that's something that we have to look at ourselves.
Yeah.
Okay.
Yeah, I think the like the exact values, the incentive crypto economic, figuring out what those constants will be is going to change, but probably the mechanisms won't. Like slashing will just be the same as Casper is today. So I think we do need this. And if you guys remember, we're thinking that the Ruby release is kind of what all the actors and pieces that will eventually go into the mainnet. But the constraint is that it probably will only run on a local network or even just one machine. So we should really be trying to target the whole system. This is sharding from end to end. It works on one computer. It won't work in the real world because that's what Sapphire is for when we're going to get the networking stuff down. So we need to try to limit the things that are not in there and try to get as much as we can.
I agree.
Yeah. So what is this processing proof of work transactions?
So what I meant by that is transactions on the proof of work chain and basically cross-linking that into the random beacon chain.
So like deposits?
From my understanding, like transactions, not deposits, but regular transactions that are going on today on the proof of work chain will still be included in the random beacon chain.
So basically for the random beacon chain, for a block to be finalized within the random beacon chain, there's a field, it's basically the main chain block reference. So before the main chain block reference is finalized, you cannot propose a block that's within the random beacon chain. So basically, random beacon chain uses the security of the main chain. Well, I think that is okay. So I think that should be pretty easy to do. You basically just keep waiting until the random beacon chain, until the main chain's block is finalized. And but then since the random beacon chain's client has the JSON RPC method, so basically you can see when the main chain block gets finalized.
So clients of the random beacon chain.
By finalized, you mean a certain block threshold is reached, right?
Yeah, basically the certain block. Yeah.
Cool.
Yeah. So you're saying that clients of the random beacon chain don't care about the specific state of accounts on the proof of work chain?
It doesn't. it basically just needs the block to be finalized.
So is it every block, or is it like a few? There's a checkpoint, like a few blocks.
I think there's every block. Yeah.
Okay.
Yeah. So the main chain is just there for synchronization reasons.
Exactly. Yeah. Because it basically keeps track of the score of the beacon chain, and then basically keeps track of the score of the main chain. So based on the four choice rule, you basically find the two highest score, and then that's your block.
That's the same as Casper. That's Casper's.
Okay.
Cool. I'm okay with like having a simple synchronization through block hashes on beacon chain. Not much else from that. Cool. So when we talk about dynasty transitions, or Preston, does it answer your question?
Yeah. So okay. So now my question is like, we are going to include these things,
Yeah,
right?
I think we should include those.
Okay.
Yeah. So we should probably like here, I'll add a section like of these.
Okay. Yeah, I didn't want to.
So dynasty transitions.
I think you mentioned that we should include dynasty transition, right?
Yeah, that seemed like it kind of seems like maybe we're not on the same page on what the spec will be, but it seemed like the dynasty transition in the spec includes changing the validator set, which I think should be included in the Ruby release.
If that's the case, then we should include. Maybe I wasn't clear on the dynasty transition that well, because he didn't really mention what it meant. But yeah.
It happens in the crystallized state, right?
Yeah.
Okay.
Yeah, basically, like for every epoch transition, the crystallized state changes, and that's once every 100 blocks. But then the dynasty transition is when there is an epoch transition and every single shard has been cross-linked, and that's when the validator set changes. At least that was my understanding of it.
Yeah, that's kind of my understanding too.
Yep, that's what's mentioned in the spec.
Cool.
All right. Yeah, and you said we can just leave out things like the reset and little things that we can just add back later, right? I think these main like core ideals of the spec obviously should be included, and all of these are important towards the full system working. So aside from that, checking signatures with BLS, I think we're going to use a simple random mechanism. I think we can just expand this and be a little more broad and be like sorts of randomness, like simple sorts of randomness in the Ruby release, right?
I think for check signature with the BLS, it also depends on what's the scale we're looking at, right? If today for Ruby release we say that we're going to have 4,000 validators, then if that's the case, then we should probably use BLS because we're not gonna write a giant loop that basically check every single signatures, and that's just really slow. Plus, there's BLS libraries that's available right now that we can use. So
if we have 4,000 validators on local machine,
yeah.
So I think it's a nice to have if it's easy to do. If it's a library, we can include it, just incorporate it. But it may not be like an exact requirement for our definition of Ruby, which is like a small local network.
Yeah, I agree. I don't think it should be feasible. I don't think it's reasonable to have 4,000 validators on your local machine.
But also, people might question us, like, why don't we have BLS, right? Because BLS is obviously a huge part of this beacon chain. It's probably the most important part to use BLS signature and stuff. So that's something that we should consider there.
Yeah. So
yeah, I guess are we? Go ahead.
I'm going to say the other question is that if we don't do this, we might be creating a bunch of technical debt. So if it's easy to do now, then we should do it now.
Yeah, that's what I'm worried about as well.
Okay. So that's something that can be ported over into a discussion on GitHub, I believe.
Yeah. Yeah, I mean, the question is, if we don't do BLS signature aggregation for Ruby, then are we going to replace it with the no-op, or are we going to replace it with some other
probably just
basically
public key and private key, like stuff like that. But then we're going to have 4,000 public keys. That's basically stored within the block.
Yeah. Okay. Yeah, that's something we can discuss.
Yeah.
Out of band.
I guess let's move on into the design.
Sure.
So, after speaking to like Justin and Vitalik, and it seems like like kind of like the attestation-based proof stake system is something that is very much in flux, and I think it's a high risk here. If we try to really pin down anything from the spec, so I think it'll just be safer to use block hashes as a source of randomness for this.
I agree.
Yeah, so there's a comment here. So cool. So shuffling will be simple. Don't have to worry about that. I'm fairly certain it's going to change.
Yeah.
So
which part is going to change? Whether after shuffled or how?
No, the source of randomness for the shuffling.
Okay, so just like step 2 is the only one that will change. Get a random seed.
Right.
Okay.
Exactly. Cool. Yeah. If we can add a note right there, that'd be cool.
Yeah. And that's fine. Like, we can still see a full system, and then kind of revisit this in a couple months when the ideas are like a little more refined.
Great. So same algorithm. We just replace active state.randall with Oracle or just a block hash randomness.
Oh,
Right.
what is this Python? What is this? This is
Python should talk.
okay.
Yeah, Preston's favorite language.
Oh, I just love not having type safety or any cool things like that.
Hey, Preston, what's the type of the number of validators left to shuffle?
I don't know, a string maybe. Who knows?
All right. So shuffling notary may not be included in Ruby release, but included here for completeness.
Sure.
So we said we're not including the cross-linking. So once again, this is probably not going to be in the release, right?
Wait. So. Okay, so we're just not going to be talking about cross-linking back to the main chain, or does this have to do with cross-shard transacting?
Yes.
Okay.
So basically, this is a shuffling for the notaries, and basically what the notaries do, they basically provide cross-link between the shard chain and the beacon chain. But since that we're not going to have a shard chain, we don't need notaries.
Yeah. Keep in mind this document only encompasses the random beacon chain design.
Yeah.
Okay. Yeah, you're right. All right. I want to dive into this, but you're right. Okay, I won't.
So we can do that if we have a sharding design document later down the line, right? So notary is not included in the first release. Point for them needed. Right, cool. So advancing beacon chain blocks, this is a very important part as this is critical to the implementation. So cool. So we can do the active state and crystallized state. We'll do this entire step-by-step per block transition. So I guess let's talk about it. If there's anything here that we can replace with something easier or if there's any difficulties. So update Randall with Randall reveal. There's already a comment here. We're going to use block hash, so no need for that. So that's probably just one step in the algorithm. We update the bit field. Anything here that you guys want to discuss?
No, I've actually read through the whole thing, and then it's pretty trivial that we can implement. So yeah, and then also there's like 3 other teams that's doing the same thing, so we can always just look at their code and to see how they're doing. But it's pretty trivial.
Great. Also, Yutaro, for the section that that updates the rewards, so basically like just checking the attesters, are we going to leave that out or leave it in, given what we just talked about? The third bullet point.
We should leave this in. Yeah. We need to leave this in. Mm-hmm.
Do we need the partial crosslinks?
We don't need
anything
related.
Yeah, we don't need partial crosslinks. And let's see. we do need to still keep recent proposers.
Yeah.
To keep track of who voted.
Yeah.
For rewards, but not the Randall reveal.
All right. So epoch transitions. Every 100 blocks do the following. So this is really important. I mean, we discussed this. I think the only thing that's going to come out of obviously is the third bullet point here. So we're not going to do any of basically nothing related to crosslinks in this first release.
Preston, can you scroll down a little bit, or?
Yeah. Tell me if I need to move down.
All right.
Yep.
Dynasty transitions. Do you guys want to talk about it? I'm just going to get my charger real quick.
Sure.
1 sec.
So basically, here are the dynasty transition, and it happens every epoch, which is 100 blocks. And then basically what it does is basically calculate rewards and penalties, and also calculate which active validators are going to be in the next epoch. And then you also keep track of the registered validators and the validators they are leaving. So if you look at the second point, it says when all shards have been crossed since the last dynasty transition. I don't think we need a second bullet point because we're not doing cross-link anymore. So that's one thing that we don't need. Other than that, everything is good.
So, hey, why we're doing cross-linking later, or we're not doing it at all?
Cross-linking should be in the next phase, which is the phase 1, and that is to align with the other teams as well.
So one question is with respect to I guess like something for demo purposes with respect to sharding. We won't be able to do that then until after we start doing cross-linking related things, right?
Well, I guess that we're not really like a sharding team, right? We are like an Ethereum 2.0 team now. I think the important thing is to build the base chain, which is the proof of stake chain. I guess it depends on what should we demo, right? Should we demo something that's sharding, or should we demo like a brand new proof of stake chain?
Both. Well, like I think it all, the beacon chain is our source of randomness, so we don't, and we're going to be using a temporary stub, just the most recent hash of the block. So like this is important, but like they're all kind of like equally important. So it's kind of hard to say, should we just focus on one? We kind of need to do both in parallel, which is great because recently we've been sort of fighting for work. So now if we can have two sets of work, that's hopefully twice as much work.
Yeah, I totally agree. I mean, I think we'll need the P2P stuff to proceed. We'll probably need like anything sharding related to proceed. So we'll talk about that towards the end of the call. But all right, so proceeding with the fork choice rule.
Oh wait, sorry. Can we go back to dynasty transitions?
Yeah.
So since crosslinks aren't included, then basically everything in dynasty transition that we have to do is just going to be rolled up into epoch transitions.
Okay.
Yeah. I'll put a note of that right here.
Mm-hmm.
Sorry, go ahead.
Okay, fork choice rule.
I added it in the meeting notes as well, Itaro.
All right, thanks.
Cool.
Yeah.
So all this, the logic that remains, will just be done as part of the epoch transition.
Yeah. So basically, this is a four choice rule for the beacon chain. So the beacon chain keeps track of the main chain.
So all we do is
based on the score of the main chain, you basically can decide which head is.
Yeah. So for dynasty transitions, we just increase it by 1 and we just update the validators.
Reorgs? So you guys want to talk about reorgs?
So fork choice rule. Anything to discuss here?
No, basically, this is the algorithm to follow, and basically, we have the spec already, and I think that's something that we should definitely do for our Ruby release.
Sure. We can talk about testing that, because I guess like Geth has probably some ways to simulate reorgs, I believe, right? And we can just we just have to figure out a way. I mean, that goes into implementation details, so we'll talk about that later. But just a way to test that in local development.
So what is the risk here? The risk is that the proof of work chain, we were on the wrong chain, and now we need to like reconcile that. Is that what we're handling?
Yeah, this beacon chain needs to be synchronized.
Yeah, it basically means if there's a reorg in the proof of work main chain, then that's really bad, right? Basically means that your beacon chains kind of mess up because of the reorg on the main chain. Because of that, your beacon chain has to readjust.
Yeah, it could be the case that the beacon chain ends up being on the Ethereum Classic fork or something.
Exactly.
Right.
So okay, can someone just explain this Python thing in plain English? Like if we reorg and we're on the wrong chain on the main chain, what is the beacon chain supposed to do? It chooses like goes back and changes blocks, or just like the next beacon chain block, it switches over to the actual canonical.
You basically just go back and then you basically look at the score of each block and make sure that within the highest score that it has a valid main chain reference. And based on that, it basically builds another queue, and then that's the new beacon chain.
Okay, so if a reorg did happen on the proof of work chain, you would see that in the recent history of the beacon chain. Like that's written in finality, right?
Yeah.
There is a main chain ref right there in the if condition. Also, like one of the things to discuss is that there were mentions that we will have to do a little bit of modifications on the main chain for purposes of fork choice rules. So I think there was a mention of like the main chain will have to implement like a promote block or something function that will make a block be higher in the queue of scores in order to handle like reorgs and stuff. You guys remember this from the spec?
Yeah, I remember that.
Yeah.
Is that what this get score function refers to?
I think so.
Yeah.
It's going to be getting the score that's going to be a function that we're going to have to implement inside of Geth.
Yeah.
So we're going to have to modify Geth.
That's basically the main chain client.
Yeah, it should be part of the main chain client, right? Like some RPC method or whatever.
Yeah.
So we're going to have to make an addition to Geth, which is an important thing to add here to the design doc.
Yeah, it could be an addition to Geth or just like a layer in front of it. If we want to keep our code separate, it doesn't have to be inside of their code.
Yeah.
Mm-hmm. It doesn't have to be inside of the proof of work chain.
Yeah, we just this whole thing needs a lot more details than
definitely
what we see here. So this needs to be like actually full design. So we'll have to.
Okay. So let's do that. Like I think reorg absolutely will probably need its own design doc.
Okay. Yeah, create a task for that, please.
Yeah. I feel like we should look at the document again and basically see how many design doc we need. Because I think for the fork choice rule, you actually need a design doc, and then there's a bunch of other things that basically needs this design doc.
Yeah, I agree with that.
Cool. I added that in the notes. So let's move on in that case. So beacon chain P2P. This is being done. That's one of the things that we discussed. I think the idea was that it's going to use the same P2P mechanism that we're using for the shards, but we can just treat beacon chain nodes as being on shard -1. That means that they're on. I mean, it means that they're on the network for shard with the identifier -1, and that's everyone just knows that's where like the beacon nodes are. That way we can use the same gossip sub mechanism, right? And since like a validator is going to be either a proposer, a tester, or notary, it'll be trivial because it's the same kind of P2P code to kind of switch that person or that that user into a network for that particular shard they were selected onto.
Yeah, I agree with that. That will leverage the same code, and we can use.
So leverage the same code, but like the validator still needs to maintain the same. It needs to establish two connections basically, right?
Yeah.
It needs to be on shard -1 because its responsibility is to do proof of stake, and it needs to be connected to beacon nodes at all times. But like when it's shuffled or selected, it's going to have to establish a second connection and connect to like a different sort of network. So you're going to be managing two different P2P connections here.
It's also tricky in a way because they did mention that each validator could play multiple roles. So basically, I have a validator. I actually could be a proposer and a notary. So basically, then if that's the case, then I need to open 2 additional P2P connections.
You're going to open like maybe 3 P2P connections.
Yeah.
You're going to have to like find peers for each of those 3 different connections across 3 different networks.
And they are also different timing as well, basically.
And you're on the same, and you're on the same like kind of client or same machine.
Yeah, I think all these details we can kind of just point to the other like main peer-to-peer design doc that's in progress, and we'll just apply the same concepts. So we don't really need. I don't think we need to talk about this too much unless there's something.
Yeah, for the sake of time, as well. Yeah, let's move on a little bit faster. So for the beacon chain node, let's talk about some responsibilities and basic things. So I think as we said, I think it should only require read-only access to the main chain. It's going to be handling the notaries. It's going to be doing the entire mechanism. Anything that stands out here that you guys want to talk about? If not, we'll proceed into proposers.
So just like talking about this, we're doing read only with the proof of work chain so that we can see new validators entering the pool. Is that why? Like
that's right. We're going to check for logs in the validator registration contract.
Yeah, and
the latest
you basically need to know the block hash of the block, and then you basically put the block hash within the beacon chain block.
Right. Yeah, so we can literally use Web3 for this.
Yeah.
Yeah.
Nothing else really to talk about there.
Okay.
Proposers. So anything that stands out here, guys?
Right. So proposers are the validators that are proposing blocks. I have a question. Is it still the case that anybody can be a proposer, or are you selected?
You basically get selected, yeah.
Yeah. You have to be selected first. So it happens on every single beacon block, right?
Yeah.
And also we want to be including the pre-image of the Randall commitment, I guess.
Yeah.
So
Do we still want to include that though, the proposer's random commitment? Because that's what's used as a source of randomness.
Well, you can just use the block hash as a source of randomness, right? And then based on the block hash, you can use block hash to select which proposer to propose.
Yeah, and since we're using the block hash, there's no need for the second point, the proposer's random commitment.
I don't think there is. I mean, we should still have that field. It can just be no.
Yeah.
Okay. And then I think the third point isn't required either because we're not doing crosslinks.
Right. Can you guys add a quick note or highlight them?
We can go back and fix it.
All right. So when we say shuffled every block, that means a new person is selected. Is it a group of validators or is it a single validator?
I think that part is still up to detail, and from my understanding, it's a group of proposer, and then basically you have your time to propose. Let's say today, if you're offline, didn't propose, and then someone next in line get to propose.
Okay.
One at a time.
Is there any penalty for being selected and not proposing? Or
I'm not too sure about that. Yeah.
Yeah, right now there's no penalty. It's just that you lose out on the block reward.
Yeah, it's decent.
Okay.
Great. All right. Should we move on to notaries?
Yes, I don't have any questions.
Yep.
So what are the requirements here for Ruby? Anything we should include or not?
Depends on if we're doing cross-link. If not, then notaries is out of the picture. So they all depends on whether we have shell chains.
I don't think we should, based on our previous discussions.
Yeah. So you can skip that part. Just go to the tester.
Okay.
Okay,
So once again, pretty simple. The algorithm is just going to do this check upon, like, receiving a block and kind of signing off on it.
Wait, so we're skipping notaries because they have to do with cross-linking, right? And we're just revisiting that phase 0 or phase 1.
Yeah.
Okay.
So a tester's that's going to occur when I receive a block via P2P and I have to basically check if it's valid.
Mm-hmm.
Basically, also when you're doing the fork choice rule, we just have to check if like that threshold of a tester signed the block.
Yes.
The attestation committee is a fixed constant in the protocol. The size, I mean, the N.
The N is a fixed community, yeah.
Cool. That's good to know. I was just wondering if it was something that could be changed.
And the testers, they're randomly selected, right? Each block.
Yeah.
Yeah.
Yep. Looks good.
All right. Let's discuss some potential scope changes. I think we already discussed this earlier, right? So we don't have to worry about shard linking. Dynasty transitions are going to be moved up to epoch transitions. Let's leave a comment here. So BLS is going to be included if it will included if there would be too much technical debt otherwise.
We need to do some research on that.
It's design, yeah. Okay.
So did you just create a task for that? Is that what that is?
We can create like an issue and then research and provide input and just go from there.
Okay. Yeah, my question is, so did we just capture that we need to make that?
I'm adding it as a to-do in the notes.
Okay, cool.
So research BLS aggregation. Right, so let's.
I mentioned here that we can just remove the fork choice rule logic, but I think it makes sense to leave that in for the Ruby release.
What does that mean? What are we removing that from?
We can leave out the logic for the fork choice rule into something a lot simpler. That would change the scope. But,
I see. Okay. Yeah. Right.
Yep.
I think we should do it because like we're working on the beacon chain already, and then without the four choice rule, then it just
kind of trivial, right?
Yeah.
Yeah.
So
yeah, I think we have capacity to do that.
We should do it.
Great. Okay. Yeah, I'm glad that this is going to open up a bunch of different things that can be done concurrently.
Yeah.
Okay, do we need to talk about active state?
So the last point is good. I think we can proceed into the project structure discussion.
Okay.
Yeah. I think, so what I mentioned here is that the random beacon chain should be a data structure that's not actively fetching data, and then allow other actors to modify its own state.
Yeah.
And did everyone read this, by the way?
Yeah, I did. So by other process, I mean like on the same. Yeah, they're gonna be like separate Go routines that are gonna be basically modifying the data structure.
Yeah.
Yeah, pretty much.
There can just be a singleton basically that we modify.
Yeah, and it could also be Yeah, it could. There could also potentially be multiple copies of a random beacon chain
on the same process.
If there's a fork. But
yes,
yeah, it's basically like a tree structure, and you just keep
that's good. That makes sense. Okay, just let me see if I have any quick questions here. No, that makes sense. So it's going to be and I guess we can persist this on each loop.
Yeah.
We can persist it to disk.
Yes.
Yeah.
Yeah.
So let's add a quick thing here. On each change, persist to disk machine. So
it's basically like what we're doing for
Yeah.
Git radio, right? This is pretty similar.
Sure. I'm okay with that. So I guess let's go down into the meat of things. Well, before we go into the work estimates, let's just talk about what specifically needs design. So let me add a section here that's like needs design. Workers rule reorg, BLS, signature inclusion, P2P where a validator can have multiple responsibilities.
Yeah. And then block transition, and then for choice rule.
Sorry, what was it?
Block transition, also
Yeah.
basically block transition. And then for choice rule, if you haven't said that yet.
Yeah, I was. If you could scroll down, Preston, I was in the section. I was adding needs design.
Oh, you're in work estimates here.
Yeah.
I didn't see that.
So anything else that you guys think needs design that we should really include?
We also should look into slashing and penalties and also rewards as well.
Yes, that is a good point. Let's add that here.
Does that need design though?
It's actually designed on the client side as well, right? How do you calculate the rewards?
Yeah, I think it does. Like, I think there are a lot of things here that we still need to design, thinking about like how our service infrastructure is going to work and how we can keep things modular. So we don't have to go in every single piece, but before we start working on anything, we should try to put at least a one pager out on what you're doing and why you're doing it.
Yeah, I definitely advocate for something more lean. I don't think. We don't need a document as long as this, obviously, for each of these items. So, okay, so let's talk about the steps then. Let's revise what we have here because things probably changed. So the idea is that we're gonna have a service registry for the beacon chain repo. What do you guys think about this?
That's good to me.
Sure. Open up a JSON connection, listen for the latest block number, block hash. Block hash. The third one, we're gonna use that same connection to listen for logs. So listen for logs from the validator registration contract. Pass in the address of the validator registration contract as an arg to the beacon chain.
Yeah.
Because I think we left out the idea that we're going to have this all done programmatically. We're just going to assume that the contract is deployed somewhere, which is the way it's going to be in production anyways. Yeah. And we're just going to be able to know, the beacon chain is going to know where to listen for, right?
Yeah.
Yeah.
So the beacon chain will need access though to the to that user's private key, right?
Why?
Because it's the same validator, right? Like Should be the same address, no?
But you only need to register once, right? So some people can register using some inferior service, and then they can still use our product, right? So you don't need to provide. You don't
Yeah, of
really.
course. But I mean, the person that registered is the one that's going to be using. It's going to be the one that's running the beacon node.
Yeah, unless you use like a staking pool or something like that. Yeah, most of it.
Oh, okay. Okay, sure. So will the beacon node need access to the private key that registered the ether in the main chain?
I don't think so.
Oh, okay.
Wait, don't they?
Aren't they signing stuff? They're participating in proof of stake.
There's, but that's a private
Yeah,
key
like
on the beacon chain. That's not a private key on the main chain, right?
I think.
but it's a private key for the address.
Yeah, but
right.
it's basically it's an identifier for, you know, I'm the person that registered 32 ether, therefore I should have the privilege of being a validator on a beacon node.
Yeah. Okay, I see. Yeah.
It's the same key, right?
Same person, yeah, same, yeah.
That's a good point, actually. I didn't think about that.
So passing address of beacon chain. So we're gonna need a beacon chain to access the private key of the validator that registered the ETH and the POW chain. Cool. Yeah, so it keeps an active validator set. I guess we can rephrase this bullet point into beacon chain becomes a data structure, state machine that that is updated by external services. The thing that we're going to have to do is we're going to have to, the first thing is node is going to have to sync with a canonical beacon chain. So it's going to have to connect to peers, ensure, you know, see what the latest number is, and then start a sync process. How is this different than, so here's my question. So how is this different than like a traditional sync? Well, I guess the fact that we have proof of stake, meaning that we have like finality checkpoints, makes it a lot easier, no?
Yeah. So you only, I think, just sync from the last finalized epoch.
Yeah, that's what makes sense.
Hmm.
We don't have to start from the beginning of time.
Is this the same Weinback that we're talking about previously?
No, this is Weinback was different. Weinback was for like the sharding fork choice rule. This is just for like traditional beacon chain, for beacon chain basically synchronization.
This is a lot simpler. We don't care about. We basically don't have to verify the last 25 blocks.
Yeah. So what does Casper do? This is what they do?
So what does Casper do? So Casper is a way of like finalizing basically blocks through proof of stake. So it is able to, it basically creates these like checkpoints.
I mean, like, how are they syncing?
So Casper doesn't define like an actual like syncing mechanism or anything. This is, you know.
Okay. Well, I'll follow up later. I want to know how because they have the same finality checkpoints, and they must have some mechanism for syncing their chain. And I'm wondering, can we use the same idea? It's okay if we don't know it, but I'll follow up later.
Okay. Right, so next one is going to be, I guess, the block processing service, right? So like, yeah, so by syncing, you're going to be fetching the blocks, and you're also going to be basically running the whole block verification algorithm, which is make sure that like enough a tester signed on it, and just ensure that everything has the correct integrity. So that's what the sub bullet point is. So then the next one is you're going to have to begin producing blocks.
I think you missed one step here in the middle. So so basically the beacon chain node will have to use a block hash to find out when he is selected to be a proposer or a tester. So there's a sampling there.
Okay. Cool. So once you are selected as a proposer, for example, you have to begin, producing blocks, listening for transactions. No, that's one thing I missed here, I believe. So Yeah, so I just have to create a block, right?
Yeah.
And I have to package. What are the structure of the beacon chain transactions? That's something that we can come up with.
You mean the block structure or the transaction? What do you mean transaction?
Yeah, the block structure. Oh, okay. The block structure is already well defined in the spec.
Yeah, yeah.
Okay. Yeah. Cool. So the Randall mechanism to select committees at respective times moved into different phases, I believe.
Sure.
Okay.
Logic for crosslink notaries as well, something that we'll take out. Logic for beacon chain fork choice. We will remove this, I believe, because that will be included. Oh no, sorry. What does it mean? Beacon chain object can just be a list of hashes or blocks. Doesn't make sense.
I don't know.
I'm not sure.
Okay, so logic for beacon chain fork choice rule. Design this and also the and also reorgs.
Yeah, I think the second to the last point can be that's out of scope, right?
Yeah, we're just using block hash, so.
Cool. So at the end of the day, just to recap, we're going to have this kind of state machine that's going to be persistent to disk. We're going to have this sort of sync mechanism that's going to be, fetching blocks and applying fork choice rules. It's going to be selecting the user as an actor in the system, either a proposer and a tester, and that's essentially it. That's the essential event loop, right? And the state machine advances. You keep listening for registered validators in the contract, and it just proceeds and proceeds. And I think that's basically it.
Yeah.
So to begin, I guess the most important thing is, where do we go? I know we're running out of time here, guys. But just to discuss, like, who wants to kind of take certain parts of the system, who wants to work on some designs. And we'll take this conversation offline and discuss it over the Gitter chat as well. But just wanted to gauge basic, just interest from you guys on either of these items.
I'm personally interested in the block processing and then the fork choice rule, basically. Yeah, that's what I'm interested in right now.
Okay. What else are you guys interested in?
I'm interested in the issue about BLS signature aggregation. What we should do with that.
Nishant, do you see something here that you want to take up?
Yeah, I'll be okay with working on BLS also, or maybe rewards and penalties. We'll be needing that too.
Cool. Yeah, that'll be good because we're probably gonna need to have a issue or a doc that discusses the pros and cons. So more people on that is always good. I'm interested in starting out with defining the state machine, and probably just setting up the structure of the beacon chain, persist that to disk, test out some beacon chain transitions just naively, like, okay, I have to do this, make sure that it's like stored in the database, and then define like the service registry for it. So that's something, I think it should be pretty trivial. Aside from that, let's see what else. So you said you're interested in like the block processing, right, Terrence?
Yeah.
I'm interested in the proposer responsibilities.
Okay.
But that's the same as the block processing, I guess. So
Together and stuff like that.
yeah. So I'm interested in the actors in particular. So I'm interested in either like the attester roles and the proposer roles. I can take over attester stuff.
Sure.
Another thing that we need is the JSON RPC connection to Geth and listening for information from Geth. If who else, if you guys are interested in this. I would also be happy to take that one up.
I guess I could take that one too, since
Cool.
yeah, I could take that one too.
I have a question real quick. Does it have to be a JSON RPC connection to get? It can just be any Web3 code to basically monitor the current main chain block, right?
Yeah.
Yeah, it can be. Yeah, it can just be a Web3 call. That's right.
Yeah, as long as it has internet, you should just walk it.
No,
Okay.
wouldn't it be better to have a JSON RPC connection?
Because it just needs to know the latest block hash of the main chain block and find out when the main chain gets reorged. That's why it needs. You don't need a running connection of Git.
Yep, that's right.
Yeah, you're right. In terms of like how the beacon chain works or how our product for that will work, it doesn't really care what's on the other side of that JSON RPC as long as it gets that information.
Yeah.
In terms of like what is best for security practices, that's kind of up to whoever's architecting how the whole system.
Yeah, I mean, I definitely don't think we should like mock the response or something. Because it's important. It's critical for us to check if like you're a registered validator or whatever, if the logs work. I mean, I guess I could just mock the logs or whatever.
Why do we have to mock anything?
No, I'm just talking like just making it simple, like how like the beacon node doesn't need to know any, like for Ruby release, as long as it gets those values, it's good to go.
Yeah, well, I mean, you can easily stand up a thing. I'm just saying, like, for this design, you can take out the word geth and just connect to something that gives you the data. It doesn't have to be Go Ethereum or Parity or whatever. Yeah.
Anything else? I think we talked about modifying geth itself, or not modifying geth, but like like we discussed like some sort of new methods on the POW that we can some new methods from the POW chain to get the score of blocks.
Yeah, some kind of scoring mechanism.
Yeah.
That needs
We should open an issue for that and basically see like who can pick it up.
Yeah, we can definitely outsource that.
Like we mentioned before, though, I don't think it's necessary. We could just instead of modifying the proof of work chain, we can just say have like 2 or 3 different Web3 calls and then figure out the score on the random beacon chain.
I think that's what we should do.
Yeah.
Yeah.
So some Web3 methods. You guys, we're going a little bit over time here. I understand if any of you guys have to go. But just to wrap things up, are there any questions? Anything that's unclear?
No, I want to chime in on what I'll be working on since I didn't volunteer for anything. The peer-to-peer piece of this is sort of just exactly dependent on the peer-to-peer design for sharding.
Yeah.
So I have been working on that. I'm going to continue working on it. If anybody wants to join me, that would be great. Other than that, I'm going to be doing code reviews, design reviews, and kind of thinking about how we can do this in sort of a modular way so that if we want to change out pieces of this, it's not going to be painful. Or if other people want to extend our client to change the rules a little bit, it's not going to be painful. So,
excellent, thank you. Also, I think nobody discussed rewards and penalties for slashing conditions. So if anyone wants to take that up later, I think after the call we'll follow up on Gitter, and I think everyone can just like add a comment on this doc and be like, hey, I want to take ownership of this.
I think Nishant said he might be interested in that.
Oh, okay.
Cool. Yeah. I think he just said it.
Awesome. Sorry for missing that, Nishant.
That's right.
Cool. So that's basically it, guys. And I think we'll probably have another discussion over Gitter over the coming days about kind of what we want to demo and what we want to put out there for the world to see, based on the work that we're doing here, and whether or not like Terrence said, like we're an Ethereum 2.0 team, so just focusing on demoing a beacon chain node, or are we going to be including any of the work that we've done for sharding in our first demo? So just want to open up the discussion on that. I advocate for whatever is more complete, and is more robust, and I think we can put together a pretty robust beacon chain implementation here. So I'm happy with that.
Cool.
Yeah.
All right. But yeah, well, thank you guys. I think won't take up much more of your time, but I think we discussed a lot, clarified a lot. Like Preston said, there's a lot that needs to be designed, but if we can just keep those designs like short and simple, well scoped, it shouldn't take up too much time.
Mhm.
So we'll proceed. I think like starting tomorrow, I'll try to get the state machine stuff going, and then everyone can, we can split up work concurrently.
Yeah.
All right.
Excellent. All right, guys.
Yeah.
All right,
Thank
thanks.
you.
All right. See you guys.
Yeah.
See you guys.
Bye bye.